Adding and subtracting decimals. Alright, so to add the following, we have 10.25 and we're going to add it to 1.356. Now just as a habit, I like to put the larger number on top. It doesn't really matter when you're adding. And then you put the other number on the bottom. And what you have to do is line up the decimals, and I'll explain that in a little bit on why. But we line them up. And then any spaces that are missing, you want to fill with a 0. You always want to make sure that every single number to the right has something there. And then now you can just add them up. 0 plus 6, 6. 5 plus 5 is 10. And you carry 1. 1 plus 2 plus 3 is 6. And then we bring the decimal down. 0 plus 1 and 1. And then that is our answer. 11.606 is our answer. Subtracting exactly the same way, but this time you actually have to put the larger number on top. So we have 1.02, and we're going to subtract it from 2. 2 goes on top. And if there's no decimal, just always think of it like money. If it was like $2, you'd write 2.00. And then we have 1.02. Again, lining up the decimals. And then now we subtract just like before. So let's just bring the decimal down just to have it there. And 0 take away 2 we can't, so we have to come over here and borrow. And then borrow again. And then there we go. 10 take away 2 is 8. 9 take away 0 is 9. And 1 take away 1 is nothing. And yes, you do want to put the 0 in front. It just marks our decimal. So we want to have some whole part to our decimal. Right, and that's it. There's adding, there's subtracting. I threw 2 more integers in here just to figure out what to do. Not integers, I'm sorry. Positives and negatives, or subtracting a larger number from a smaller. Okay, so like I said before, we put the larger number on top. Put the other one right below and fill in any spots that are missing. And then we look at it and see we have a positive number, and we want to treat this one as a negative. Remember, when we have adding integers, we have 4.32 minus 58.125. And whenever we subtract, we want to always put a plus there and a minus there. That allows us to say, okay, this is a subtraction problem because one is positive, one is negative. They are opposite signs. So this is subtracting. 5 take away 0, 2 take away 2. 1 we can't, so we come over here and borrow. In fact, let's do that in red so we can mark it. That's 7. Put the 1 there. Alright, we come back. 11 take away 3 is 8. Bring the decimal down. 7 take away 4. And then 5. And larger will always decide the sign. So the 58 is bigger than 4. So it is minus. And then that is our answer. Alright, now if we have a negative and a negative, so remember this is plus minus. It's 2 negatives, which means we are going to add. And we always want to keep that larger one on top just to keep that same format whenever you're adding or subtracting, and then fill in the 0, the spacer. So now this is an addition problem because they are both negative, which means if you add 2 negatives, you get a negative. 3 plus 0, that's 4. That's 4. Bring down our decimal. It's 12. Carry the 1 and 6. And then that is our answer, negative 62.43. And that is everything. That is what we have for adding, subtracting. We have a positive and a negative, and we have 2 negatives. Now we still have that same rule, so if you had negative 1.32 minus a negative 4.5, this would still become negative 1.32 plus 4.5. It's just like, it's the same rule. It's going to apply for everything. So when you subtract a negative, it'll still be a plus. And with this particular problem, we would be subtracting because one is negative and the other is positive. Okay, so why do we line up the decimals? Well, if you remember back when we did adding whole numbers, pretty much adding anything, fractions, if you put that plus sign in the front, what we are doing is counting. So if you see 1 apple and 3 apples, remember that number in front tells us that quantity, that value of our quantity of apples. This is 3 apples, 1 apple, for a total of 4 apples. So whenever you see plus, you have to add like terms. So if we look at 17.6 and 2.35, 17.6 translates into 110, because that's what the 1 stands for right here. These are the tens. And then the 1 is the 1, the 7 is in the ones. And it tells us how many set ones we have, which is 7. And then the 6 is in the tens place, so it tells us how many tenths we have. Same thing, 2 is in the ones. This is the tenths, and these are the hundredths. So that's where we line up the decimals. So our ones are with our ones, our tens are with our tens, and then our tenths are with our tenths. I mean, if you just think about it like money, if we had $17.6 plus $2.35, you would force yourself to go 17.6, 2.35, because this is money. These are $10 bills, these are $1 bills, these are dimes, that's why it's tenths, and these are pennies, and you'd want to fill it in right there and make sure everything matches, because that's what our money looks like. So that's why we have to line up our decimals. And just to give you another look in why everything is working the way it is, if you notice here, over here we have wholes, and over here we have fractions, and that's what the decimal separates. We have our whole part and we have our fraction part, so it also separates our two. 7 plus 2, we had 9, plus 10. 10 plus 9 is 19. And then over here we had 9 tenths plus 5 hundredths, and that gave us 95. Alright? And if you look at over here, it's 5991. 19.95. This is just so much cleaner than doing all of this. But you have to remember, no matter what, how you look at it, no matter how you look at these numbers, that decimal and the other decimal have to be lined up, because they are separating whole part with fraction part, whole part with whole part, fraction part with fraction part, and they're actually placing the place values exactly where they're supposed to be. So you are adding together tenths, hundredths, and ones.